All the microphones are open. We cannot find a way to stop, so we have to be careful. Well, yes, I don't know how to stop the system. Yes, be careful. Okay. Yes. Well, welcome here. Welcome in the SMTDA 2014. And I'm very happy that a large group will join us here in Portugal. For me, it was a challenge to be back after 86. I was 86 here, giving my first plenary talk in a place close here in Carlos Gulbenkian Foundation. For me, it was, of course, a very difficult day because I was very young. It was my first plenary talk, and the sound was crowded, very, very big, and a lot of people. But okay, it was a nice experience, and also I was fascinated about these people here and the place, and all this history, the last few centuries, traveling all over the world, finding new places, establishing new population, new countries, everything. It's something very important, this history. And of course, we have scheduled a half-day excursion in the town. And I think you enjoy that all this tour from some special places. Of course, the places are very many, and the history is huge. I expect that you can find more things from the local guides and from the. So, here we thank, of course, the local people. Yvette Gomez helped us very much from the university here, and Elena Baselani-Nicolaou, to the right of me, she has organized in '99 one of our ASDA conferences here in Lisbon, and we thank again even from this morning, and we asked her to give also a plenary talk in the opening. Well, of course, the other two here, Sally McLean and Raimondo Manca, and me, we are in the main group, in the chairing group of ASDA from many years ago. Of course, ASDA started in '81. No one started in '81 to be, but we are more than 20 years in this group, and we continue. And I thank them also for the help and support for all these years. Well, the previous SMTDA, we can explain also. We have the main conference was ASDA. ASDA was Applied Stochastic Models and Data Analysis. We started in '81. Professor Jack Jansen was the founder. We started in '81 in Brussels, and we continue after in Brussels, in France, several places, and after in Spain, in Greece, in Lithuania, here, and again here for a certain time. So ASDA is scheduled every 2 years, but and we follow this. But after the last decade, it was a serious problem because the people asked us to organize something in between, because now the things run very fast with the internet and emails and all this, and so we started from 2010 in Chania, in Creta. We started the first SMTDA. It was successful. We continue with another SMTDA also in Chania, Creta, and now is the third SMTDA here in Portugal. Of course, I think that from today we can connect both ASDA and SMTDA, and to know that every year we plan to have an event every year. We call it ASDA SMTDA, but it's the same event, and the people joining us is almost the same, from the same groups. This is exactly that I told you before. The SMTDA started 10, 12, and 14, and we plan. We have already visited Malta and the University of Malta in La Valletta. It's a very marvelous place. With also, they have a very important history, a very interesting history. Fortunately, they have also, there are connections, perhaps plane connections, perhaps better than the connections we found here, because we have here to come with changing at least 2 planes, even with us living here in the European territory. I'm afraid also we have also in Greece we have some similar problems that we have to make connections. With this ALTA and SMTDA conference, we run also the demographic workshop. The demographic workshop started in 2012 in Chania, in Crete. It was a successful try, and the second was last year in Mataró in Barcelona, Spain, and we continue here. And we plan also the next demographics 2015. I'm sorry for the mistake here. It's 2015. Will be in Athens, in Greece, in the University of Piraeus, where also we plan to be the ASDA for the next year. And if it continues to be so successful, this workshop, demographic workshop, perhaps will be different, to be separated from the conference, but this is up to decided in Athens next year. And about the SMTDA, we say until today that the sponsor was ASDA, and it's true that they help us very much, and we thank, of course, ASDA. But as I told you, we continue with ASDA SMTDA as a group. The honorary chair, as you understand, is Professor Jack Jansen. Is emeritus professor of the Université Libre de Bruxelles. He's not here. We don't like to travel much nowadays, but you have his greetings. And about the plenary talks, Elena Vassilou-Nicolaou starts the plenary talks. And Isabella Fraga Alves, I'm sorry, I'm always found difficult to pronounce the Portuguese, because I have to say, yes, this is my pronunciation. Isabella Fraga Alves, we continue. She has also a presentation, a plenary presentation on estimate the right endpoint and way. But I can say also from the beginning, from Elena, that she has done a very good work in data analysis and some classification problems, and also she's for many years active in this field, and she has done a lot of work on this. And of course, in the third place, it's Paulo Lisboa. Of course, it's not the places are alphabetical, of course. But it's Paulo Lisboa. It was very interesting for me to invite Paulo Lisboa, because the name also is Lisboa. It should be from here. Of course, he's in England, and he will give us a talk on approaches on the interpretation of machine learning classifiers. It's also important because this part of studies should be a part of ASDA and SMTDA. And Arthur Pérez, the name looks more than British name, but it's from Spain, and it's an interesting talk about modeling toroidal data using circulars. It's a a term opposite to copulas we use. He's British. Ah, so it's okay. He's British. Okay. And after we have a very also important talk on demography, and Jean-Marie Robin is here, and he has to present here the last trend about demography. He's chairing several important groups in Europe, and he's also involved in several very important projects. So he has to give us the up-to-date case in demography and trends and gaps in disability-free life expectancy among the European countries. And okay, for me it's perhaps the first time that I added a plenary talk in our conferences. Usually I give small talks, but for me it's important this year because I have finished a big project started 20 years ago, having to do with demography and applications in demography, and so I feel that it was my duty to present it in a plenary talk. So I thank you if you join this, my presentation. Okay, we thank the International Scientific Committee. There are people that work can help us in the presentations, in the program, in the publications. Also the special session organizers and all the conference contributors, the organizing committee and the secretariat. The secretariat, we know already, Mary Karadima is our secretary, and Alice Melletiu has helped us with the electronic system and all this. It had revitalized our system because starting in '81 we started with not an electronic system and not a system with computing and all this. You saw today that we have made a progress in this program. And a young one, Aneta Kumi. Aneta was the young girl very young girl in the registration desk. About the conference tools, we have presentation and posters, the book of abstracts, proceedings, including the papers presented, books. Always, almost every year we publish books. You already have found in your bags. There is a flyer of one of these books. There is another book in progress, and I was responsible for the delay. It had to be ready here, but the flu during April let me down on this project, and we plan to have it ready during July or August, something like that. And so you find the information. Of course, we have electronic dissemination through the conference website, and some details about the conference today. The program was published almost 1 month before. It was important for this, and so we have done changes. And in front of the rooms, because we have 4 rooms, here is for the opening and the plenary today, but after we have 4 rooms close to the registration desk. And so in these rooms we have all in the door of the room there is the program with last minute changes. And also for the session chairs, because some talks, in some sessions, the talks are only 18 or 20 minutes, or sometimes less. Please, the chairs, check if someone is missing. And if someone is missing, please split his time to the other. Yes, we tried if someone was not sure if he's here, usually due to visa problems, because a serious, every year we have, this is an international conference, and this problem with the visa, it's always appear. And also financial and economic problems. And okay, about the excursions, there is a half-day excursion tomorrow after lunch. The buses will come here in the front of the hotel, and they pass from several places of the town with a guide, of course, and we explain us, and we have time to take photos. The conference dinner, we have found a nice place in Hotel de Naciones, close to the sea. They call it bacalao because bacalao is the famous fish here in Portugal. We have tested there, and the food was perfect. So you can be sure that, and the wine is good, and everything is fine. So the only thing is that perhaps in the program was that this dinner starts, you have to be here at 8 o'clock, but we have changed, and you have to be here at 7 o'clock in the afternoon, because we'd like to benefit from the light from the place. You know, if it's good weather and the light is better to go earlier. And we finish at 11 o'clock. There will be buses here and buses to take up us from the also from the dinner at 11. Okay, another point I would like to say about the day registration. Day registration, it was an idea facing the economic problems. So it's a good solution, but also there are people that are missing the other days of the conference. So we try to reconsider this, but until now we have this day. We see it's up to we see this week how it's going this. Okay, and the papers in final form, we expect to have the papers in final form in July 20. And we plan after, and we ask you if you would like to have your papers not only in the electronic proceedings and in the web, but also if you would like your papers to be included in books. And so, but you receive, I expect to have your papers by July 20, and after you receive information about the publication. It will be at least 2 publications, the one about the conference and the other related to the demography workshop. This is for sure. But if we have an excess of papers, sure it will be another one. Okay, about the publications, it's okay for this. The scientific committee is quite big series. We thank the people. Oh yes, perhaps there are few. Okay, about also the publications that we have a series of publications. In '93, the first was I was editor in this publication, or co-editor. I'm happy that these books of proceeding books continue even now to be in the market. The publishers continue to publish and republish these books, and also the book from '95 by Kluwer. This was by Kluwer here. It was republished by Springer, and they continue to sell for 15 or more years or 20 years. This. And of course they continue. The records I have about our proceedings books are very good. We have quite big sales. The publishers, of course, because we don't get sales from these books. And we have also a series of special issues in journals that almost not every year, but we continue to cooperate with these journals and to have this. Okay, And next that will be in the University of Piraeus in Greece. They have enough experience about that. Yes, there are people from the organizing committee in the University of Piraeus. Bersinis is Sotiris. So, okay, he will present us later this. And of course, we have people also from the University of Malta. They give also a short presentation. So, I'm sorry for all this long talk, but I would like to explain everything about the conference. And give the talk to Steve.
Okay, good morning to everybody. I'll be short for sure because Professor Skiatis already said the most important things. On behalf essentially of the University of Lisbon and the Center for Statistics and Applications of the University of Lisbon, I would like to welcome you to this third SMTDA. I think it's in its third edition, but despite of that, I think it's already a well-established scientific meeting, as the overfull program clearly shows. And this is essentially due to the energy of Professor Christos Skiatis, to whom we should thank. Okay, aside from the exciting talks and discussions that we are going to have for sure in this meeting, it is expectable that at this time of the year the weather is fine, and I think it is. I saw the temperatures there, 31, 32, 36, 33, sorry, so maybe a bit too warm for you, but okay, I think it will be fine, and so I hope you enjoy your stay in Lisbon. As most of you probably know, June is a very special month for Lisbon. Since the town patrons, which is Saint Antonio, okay, Saint Antonio, is celebrated on June 13. So in 2 days we have the day of Saint Antonio. The day of Saint Antonio is usually preceded by a night of what we call profane folly, namely at the old Alfama, so you can go there tomorrow in the evening after the conference. You can go either to Alfama, Moraria, Bairro Alto. So these are all places in Lisbon where you have dances, a lot of our typical grilled sardines, you know, so those small fish that for sure will be very expensive at this time of the year, but anyway, if you want to try them, tomorrow evening is a nice day for that. Also, we have what we call marchas, those popular dances and colorful dances, which will be at the main avenue of Avenida da Liberdade tomorrow, also, I think in the evening. And okay, a lot of other things related related to Saint Antonio. The demanding program of this workshop will keep us busy during these 4 days, but nonetheless, I think that we'll find some way to go to these social programs, and so I wish you a fruitful stay, both scientifically and social. Above all, I wish that this meeting will strengthen your knowledge of the field and will have a positive impact in your careers. That's all. Thanks.
Well, Sally McLean, yes, from the committee of the Athens.
Good morning, everybody. I'd like to add my welcome to you all to SMTDA 2014 and to Lisbon. I'm sure we're going to have a great conference. I've seen the programme and it looks very exciting. I've seen the weather and it looks quite exciting as well. Lisbon's a very nice city. I've just been once before, but that was to the 1999 ASMDA Assembly Conference, and we had a very nice experience there, and I'm sure it'll be at least as good this time. So I first came to these conferences in 1993. I'd been at a few workshops before, but I went to ASMDA in in Crete, organised by Christos, and it was beautiful weather, lovely wine, very nice talks, and it's such a nice conference. I ended up volunteering to organise ASMTDA in 1995, which was in Dublin, so since then I've missed very few, and since SMTDA started likewise, so I hope those of you who are new to these conferences enjoy them as much as I have, and I see many of the old faces, so I think that says everything. So have a good time.
Well, and Raimondo Manca from...
Well, there are Christos, I don't remember his name. Yvette. Okay. And sadly told many things. I don't like to speak too much anyway. I am, how to say, happy to be here. I stayed also in 99 in Lisbon, and I was also in Dublin. It was for the first time for ASMDA, and so I think that this is the continuation of our tradition, and we hope that you will enjoy to see, and I hope that, I know that there are a lot of very good presentations, and so I think that from scientific point of view it will be a very good conference as usual, and this is enough. Thank you very much. Bye-bye.
And also Elena Vassilou-Nicolaou, she was in Creta in '93 when I had organized my first conference there. And also after she organized the '99 conference here. And good memories perhaps. Would you like to say a few things?
And I was also in 2010.
Yes, exactly.
No, I think that you said the most important things, all relevant things. So for me, I just want to say, enjoy your stay in Lisbon and let's work.
And okay, it's the time to start the first. Yes, to start the first plenary talk. Elena Vassilou-Nicolaou will give the first plenary talk, and Raimondo Manca will chair this plenary. Okay? Okay, so we move from this table.
And I stay here.
Yes, yes. SMTDA? You can take this thing.
Okay, I think we begin because it is late.
Yes.
So the first talk is by Elena, and is on cluster analysis of complex and heterogeneous data. Please, Elena, you have half an hour.
Okay. Can you inform me about the time?
Yeah, I will give you.
Thank you. Well, first of all, let me thank the organizers who invited me for presenting this talk on cluster analysis of complex and heterogeneous data. Maybe you like that. Yeah, it's okay. Thank you. So I split the presentation in those points. I will say if I can speak about all those 6 points. That be an introduction to complex and heterogeneous data. Then I will speak towards measuring similarity between complex statistical data units and about data representation of those kind of data. Then about a global similarity coefficient that we need to measure similarity between SDUs, and then two examples, two applications and some conclusions and future developments. So, cluster analysis, also called unsupervised classification, mainly for people working in pattern recognition, concerns a set of exploratory multivariate data analysis methods and techniques for grouping either statistical data units, we are going to speak about that, or variables, we are not going to speak about that today, into groups, or we say clusters of similar elements and well-separated groups. So we are interested in finding what we call a clustering structure, an underlying clustering structure into the data. In classical clustering methods, statistical data units are usually are first order, what we call first order elements, that is subjects, individuals from a sample or a population, and they are described by usually homogeneous variables in a matrix like this one. So the general term in this cell, we have a single value, which can be binary, count, real value. So only one value. What happens with what we're going to explain? Instead of having statistical data units of first order, we have second order or more objects. That is, we are going to work with not only an individual, but groups of individuals. And we can have samples of a population, subsamples, even classes of a partition. In what concerns variables, they may be complex in the sense they are, we shall see, the sense of complex, and of different types of heterogeneous variables. So we are going to speak about binary vectors, simultaneously dealing with binary vectors, multi-valued probabilistic frequency distributions or histogram, and interval variable types. So instead of one single value, each cell of the generalized table, like we will see, contains a set of different values, and we are interested not only in studying the information given by the individuals, but also we have to study or to take in account the internal variation in those cells. So we are going to speak about three types of variables, generalized variables, categorical or modal variable with MJ modalities or categories. Then YG prime represents MG prime dimensional binary vector, and then another variable representing an interval variable. So in the old matrix X, each cell will contain a frequency distribution or an element of a binary vector with 0 and 1 in the components, and an interval value, an interval of the real axis. This is how we can representing such kind of matrix. So here you have frequencies, distribution frequencies. Here we have the binary vector, and here the interval variable. So we speak about having symbolic, complex, or three-way clustering approach, and for that, of course, we need different methods or extended methods for the usual clustering methods. I have here some information about, but it's about the reference, but they are also in general bibliography. So I took two examples of that, and we can see already the matrices. This is a well-known example, well-known by people, mainly by people working in classification and clustering and statistical with complex data. Here we have not individuals, not subjects, but samples of fat centiloids, and they are described by 4 interval variables. Specific gravity, freezing point, iodine value, saponification value, and finally by a column which will be treated like a binary vector, where we have 9 measured fatty acids. So they are described below, and we shall see how we can treat the let me see. No, it's not going there. Oh, okay. The other example is also very well known in classification and clustering literature. It's horse data set. Here, so the data, the statistical data units are not individuals, are groups of horses. They are represented. Is the transposed matrix here. So these are the statistical data units, groups of horses and races. Here we have the variables, and you can see that we have two kinds of variables. The 3 first ones are histograms, or distribution frequencies. They are represented here. In fact, this is the distribution function. The distribution frequencies are relative frequencies. We sometimes call about probability vectors as well, or histograms. And then we have seven interval variables. For the 3 first variables, we have respectively 15 modalities or categories, 10 and 9, and then this is also corresponding to modalities, but they are elementary intervals for each variable. For each interval variable, we are going to split them in elementary intervals in order to work to perform the cluster analysis methods. And in fact, okay, I'm at the end, but not, how can I, can you help me? For coffee. Okay. See, it's okay. Thank you. Thanks. So I was here, and I was telling that in order to perform cluster analysis, of course, the data matrix after transformation, we shall speak about that, will be that one. So Here we have, as usually, data units in rows, and then, for instance, for the first histogram variable, there are a certain number of categories, and for the others, this is the last one, the last interval variable. We have also some values which I explain later what they represent. Actually, when I was speaking about this kind of mixed data with someone who is working in questionnaires, she told me, this is very interesting, but for me, I am interested in questionnaires, so what can you do with that? So in case of questionnaires, of course, you usually have often homogeneous context, and your variables are like this. You have categorical variables, so this kind of a representation. In case you have, let's see, if you have the representation of data, the representation is like that for two columns. So you have two variables. Each variable have a certain number of categories, and here you have your statistical data units, and you very often want to classify either statistical data units or, in this case, variables. So you have to classify subtables. I'm not going to speak about that, but you can do that with our approach. This is a particular case which in fact, in this case, all the variables have the same number, and it happens quite often for questionnaires, have the same number of categories, so you are in the classical three-way matrix for data representation. Now, what can we do when we want to classify such kind of data? So far there are two main alternatives. Either we transform all or just one part of the whole data in order to obtain homogeneous data, or alternative, we find robust statistic methods to deal with different types of data. And our approach, the approach which I will explain very fast, is in the second alternative. First question: how should we measure similarity between statistical data units in a coherent way if different types of variables are involved? Usually, in the second alternative, I'm told, we have to find partial or local statistical data unit similarity coefficients for each type of variables. And then we combine all of them in a convex linear, usually in a convex linear combination, which gives a global similarity between statistical data units. Of course, such procedure should be performed in a consistent way, combining comparable local similarity coefficients into a valid and robust global similarity coefficient. So we are going to describe an hierarchical clustering approach for that, and including the three kinds of variables I told before: discrete and categorical or modal variables, binary vectors, and interval type variables. What we will get is a similarity matrix, and several similarity metrics for local similarities, and finally a similarity matrix for the global coefficient. And then from that similarity matrix, there will be aggregation criteria, which will lead to hierarchical clustering methods, hierarchical clustering models, explicative models in this case. So what hierarchical clustering analysis wants? The aim is to extract relevant, suppose that is relevant, hidden knowledge from large databases in the form of hierarchical structures. This is much important nowadays in what we call big data. We have a lot of big data coming, and we have to analyze this big data with multivariate exploratory data analysis methods and techniques, robust and with several kinds of variables in there, in the databases. So, concerning discrete and categorical variables, well, the idea is for each kind of variable, we are going to associate a subtable, some kind of subtable, in the whole database representing our data. And so, in fact, in each subtable, we have always a general term which we call XKGL. For the next variable YG prime, it will be XKG prime L, and so on. They are all real values. They are all, in each subtable, they are different. They are different values. In this one are frequencies. The next one, it will be 0 and 1s, because we will have a binary vector. And finally, we will have in the subtable representing interval variable, we will have interval ranges. So we have not time to explain all of this. So let's see. The important thing here for the first kind of variable is that as we have frequency data or discrete probability distributions, when our problem to find a similarity, a partial local similarity between each pair K prime of SDUs will be that we have to discover or to work with similarity coefficients for probability distributions. While in the next case, for binary vector, for a binary vector, so here we have the partial, the subtable associated to the binary vector. Here, instead of frequencies, we will have 0 or 1s. And the important question is that we can also compute our similarity coefficients from the well-known 2x2 contingency table associated to each pair of SDUs. Then, for an interval variable, we have the same aspect, except that here we have an interval range, and that we have to compute all these things, of course. Moreover, a similarity coefficient for 2 rows here can be computed directly from this table, or indirectly from a new generalized 2x2 contingency table, where here we have, instead of cardinals, as usual, we have interval ranges. Okay, so a local proximity for interval data can be defined in both ways. Finally, for a global affinity coefficient, so what can we do with it? A global similarity, a global similarity coefficient, should be a binary coefficient for binary vectors, a generalized binary coefficient for interval variables, a probabilistic coefficient for modal variables. Conditions 1 and 2 are satisfied by a large set of coefficients, but the three conditions are not satisfied for so many coefficients. Affinity coefficient satisfies all the conditions 1, 2, and 3, and has as particular cases the OKI and the generalized OKI coefficients, which are well-known coefficients. So this is the general aspect of the affinity coefficient. Is a linear combination of local similarity coefficients, and it's easy, or it's not difficult to prove that the local affinity coefficient applies simultaneous for histograms, binary and interval variables. I have here just the expressions. For histograms, we have frequencies instead in this place. For binary vectors, we have 0 ends, and this is the OKI coefficient. Or for interval variables, we have this expression and the generalized OKI coefficient. Let's go for the examples. So the two examples I told before. Here we can see a very fast test. We have the data. Then these are a representation of an interval for some interval variable. Let's go. These are the data representation for the measured fatty acids. It is a binary vector. We have applied the affinity coefficient and also a standardized affinity coefficient which is related to a probabilistic version, VL probabilistic approach. These are the metrics. Of course, we have one in the main diagonal, and the affinity coefficient takes values between 0 and 1. Standardized coefficient don't. So we could not see, yes, because it's not possible to return. Okay. These are two graphic represent to the engrams representing the results, and we could see that these are nice results comparing with other methods that have been used by other authors. Okay, and very fast for the second example. When we apply what I have told about the three data representations for each kind of variable, we obtain this whole matrix. Okay. It happened again. Não sei o que é que se passa. Vai lá para o fim de 25 para aí. Não, mais. Sim, aí. É assim. O anterior. Ok. Sim, ok. Thank you. This is the data representation. These are the similarity metrics with generalized affinity coefficient. These are the results in the form of an histogram, so we could, but I have not time. But something is in the extended abstract, and it will be in the paper. we could compare these results. We could measure, we could validate the results also with several validation measures. We could compare the results between those both trees, both dendrograms, and also with the results obtained by other authors. And well, conclusion. We have proposed three natural approaches for data representation when histograms, binary, and interval-valued variables are present in the database. They lead to a comprehensive approach for measuring global proximity between complex data units. The weighted generalized affinity coefficient holds for mixed data described by those kinds of variables. It is a similarity coefficient for comparing distribution laws, gives the OKI and the generalized OKI coefficients for binary and interval variables, respectively, and may be represented by the same mathematical expression for all three types of variables. So a unique algorithm works for those three types of variables. So the present work synthesized previous methodological results and shows some developments very fastly, mostly regarding data representation, which is very important for us, and hierarchical cluster analysis of three-way and of symbolic data, where statistical data units are heterogeneous and complex variables. Next future developments are analyzing adaptive families of probabilistic clustering method and models and computational upgrading. We have applied this approach to several kinds of data already, mainly in health sciences, education, economy, and management. Okay, now we have some main references. Of course, we have no time. If you are interested, you will speak to me later. And okay, we finish. And we finish with horse data and olive and oil and fats and oil data. For those of you who will be next week here, there will be an international festival with our Lusitano horse, and of course with Cristo spoke about bacalhau and olive oil. Welcome to the dinner, and okay, it's all. Thank you.
There are comments, questions? Okay, thank you.
Yes, we continue with the second plenary talk by Jean-Marie Robin. And also there are the presentation of Piraeus and University in Malta, which we have no time now, but after lunch, when we start the next plenary, we'll have the opportunity to give the presentation. Jean-Marie.
Very easygoing Mediterranean style, in particular.
Okay, we start the second plenary talk by Jean-Marie Robin from France that has a lot of work on demography and also this important part having to do with how we estimate the disability-free life expectancy or other things of life expectancies is a very important part also for the countries and for societies. He has joined groups and he's leader of groups in the European Union, in the World Health Organization, and he's working more than 25 years on this field. I'm also working for 25 years in a parallel field, but it was a pity that only last year we have met in Mataró. So, Jean-Marie.
Thank you, and thank you for this nice introduction, and also for inviting me again. And it was already a pleasure last week to meet you and to discuss with you and to see whether we can work together. I mean, the two networks, the two societies in the future. And so this year the question is, what is the relationship between longevity and health? And I will try not to say the same thing I said last year, I will see. So almost no one questions the positive association between health and longevity in that way, health to longevity. It is expected that healthy, robust people will live longer than frail people. And in fact, we are observing that today when we are now following nonagenarians or centenarians. On the other hand, many people wonder about the relationship between longevity and health. And so the other way. Are we living longer because we are in better health? Or are we merely surviving longer, whatever our health status, because just medical progress? So in the past, and in fact, since the 80s, the beginning of the 80s, we have a corpus of 3 theories in public health and epidemiology, and maybe more specifically in medical gerontology or in epidemiological gerontology. The first one is coming from James Fries, and according to him, life expectancy in the 80s was close to its maximum, and medical health and health behaviors, you know, at that time we were just discovering the importance of physical activity, diet, smoking and alcohol consumption on the health status and on mortality. So the expectations that medical and health behaviors progress can only reduce the number of bad years to a small part of the life expectancy. And it is what he called the compression of morbidity. On the opposite, at the same time, Grunberg and Kramer observed an increase in the survival of demented people. Small group in some nursing homes, but it was enough for them to build the opposite theory that medical progress will increase the survival of frail elderly people. In between, Ken Manton proposed a dynamic equilibrium in which increased survival is offset by better control of chronic diseases, keeping the proportion of the life in good health more or less constant within the life expectancy. So, in fact, at that time, we were observing, and not understanding, but we were observing some increase in the number of old people, some decrease in their mortality, and health authorities and administrations were worrying about the future health status of this older and older population. So this led them to build health information system in the 80s, at least in some countries, in the United States, in the US, in England, in the Nordic countries, or even in France, including repeated cross-sectional health survey, which allowed the functional health status of the older people to be monitored. But no theory on health at that time was anticipating the longevity revolution which is currently occurring in most developed countries and which has led to impressive numbers of nonagenarians and centenarians. I think I said a few words on that last year. Maybe I showed this slide, but I made some changes. And here you have a picture of this longevity revolution in France, where we have good data, at least since the beginning of the 19th century. So here you have the distribution of the individual life durations for the females starting in 1827, and you have one distribution every 20 years. So until the last one is 2007. And I will show you first what we know, what we are teaching, not in primary school, but in high school, I think now almost everywhere in the world, about the demographic and the epidemiological transition. During the demographic and the epidemiological transition, which occurred in France at the end of the 19th century and during the beginning of the 20th century, we first observed a huge decrease in infant mortality. And in parallel, we observed an increase in the number of people dying as adult people, as elderly persons. And this is really what we are observing in France until the 1930s. But without any change in the distribution of the adult life durations. Adult people were dying around the age of 70, 72 years. And this was not observed. Even if the data was there, only until very recently, the distribution in France from the 30s started sliding to higher and higher ages, and this was leading to the emergence of new segments within the population with centenarian and with nonagenarian and centenarian. And this is what we call the longevity revolution. It's a longevity revolution of the adult, is the adult population. Is no longer dealing with the fall of infant mortality, allowing more kids to become adult and to die as adult people. And just to give you a better idea of the importance of this demographic transition, in France, in 1907, so I need, sorry to put my in 1907, so it is this one, so it is this distribution. So it's about exactly 1 century before. The most frequent age at death was close to 70 years. And no more than 2%, in fact less than 2%, in this mortality condition of the beginning of the 20th century was reaching the age of 90 years and dying after this age. In fact, 1.7%. But in the mortality condition of 2007, so this one, last one here, in this mortality condition, so the most recent, almost 40% of the French women will reach their 90th birthday before dying. So you see we are moving from less than 2% to 40%, and in the coming years, I guess, much more than 50%. So this is really this adult longevity revolution. So we are trying to answer this question about the relationship between the increase in longevity and the functional health status of the population at 3 levels: individual, national, and global levels. At the individual level, the question maybe are centenarian people healthy people? At the national level, the question maybe is healthy life expectancy for the whole population increasing faster than total life expectancy? And you already said a few words about. At the global level, the question maybe, do countries with the highest life expectancies have the highest healthy life expectancies? So, for the first questions, are centenarian people healthy people? We really have a few representative studies of centenarians, and less than half. We don't have 5. And in fact, these studies, we have one in Denmark, in Italy, in Japan. In general, like here in Italy, they show that about 1% or less of the centenarians, when we are really trying to get a representative sample of the centenarian population, are fully independent. So they don't need help in the daily life. That means the opposite is 99% of the centenarians in Italy, they need to be helped on a daily basis to survive. So okay, some of them, and we like on the TV to say the centenarians are in good health, but this is the reality, at least from a public health point of view. But on the other hand, many studies, and good studies, are suggesting that these extremely old people, they were in relatively good health when they were 95 or 90. It seems it's like when we are visiting them when they are centenarians, it's too late. We really wanted to wait too long to see this extremely old person, but the one we are seeing when they are 100, talking with them, talking with their family, it seems that they were not surviving in bad health for years and years. And there is a very good paper about that published by Christensen and in PNAS a few years ago, where you can see that in Denmark they were following extremely old person from the age of 93 to 100. And because Denmark is a small country, they did not draw a sample, they were just following the whole population. So all the people 93 in Denmark belonging to the cohort born in 1905 were met and followed until today. And in fact, you can see this is the prevalence of people independent in the daily life. And you can see that, sorry, here. You can see that at the beginning, when they were 93, about 39% of them were independent. And becoming older, you can see that the prevalence of being independent is not changing anymore. It's flat. You know, it's something which is including all epidemiologists and demographers, is the shape of the mortality trajectories or the prevalence trajectories with age. It's very easy, increasing in general following an exponential trajectory from age, let's say, 65 to 85 or 90, but after that is not clear, and there is a lot of results suggesting that these trajectories are moving or reaching a kind of ceiling. And this is a perfect illustration of that, because the prevalence of being independent, or the opposite, the prevalence of being dependent, is almost constant in Denmark after the age of 93 to 100. You can see it's about the same proportion. But of course, we have less and less people. We start with more than 2,000 people in Denmark, 93 years old, and we are ending with 156 people reaching the age of 100. But we always have about the same proportion of people independent. But if we look because these are a follow-up, these people are closely followed from the age of 93. If we look at what was their initial health status when they were 93, we can see that this group, 156, where still 32% are independent, which is exceptional. You see, when they were 93, 70% of them were independent. So in fact, we can see like that this group is a very selected group of the people age of 93. And frail people died like that. The prevalence of people remaining independent remained almost flat between the age of 93 and 100 because the mortality selection. So, our question is, are older people more likely to become centenarians because they are in better health today, or because it is much easier to survive today than in the past? And here, we have identified 3 situations where the data are quite good: Denmark, France, and Japan. In Denmark today, the number of centenarians is increasing very, very slowly. We don't know why yet, but it's like that. And you can see some figures here. You can see that from year to year, the number is increasing, but very slowly. Very slow increase in Denmark in the number of centenarians. In France, you can see here the numbers are quickly increasing. In fact, they are doubling every 10 years. And this is a good summary of what we are observing in Western European countries. Today, the number of centenarians is doubling about every 10 years. But in Japan, it's going much faster. The number of centenarians is multiplied by 3 or by 4 every 10 years. It's really skyrocketing. And here you can see in 4 years, the number are already almost doubled. So we really have these 3 situations: slow increase, middle increase, and very fast increase. And in Denmark, where the number of centenarians is slowly increasing, in fact, we observed a clear improvement in the functional status of the centenarian. Increasing very little, so the mortality selection remaining about the same, but the functional health status of the centenarian were improving. On the opposite, in Japan, where the number of centenarians was skyrocketing, and here you can see the number, the actual number from 1973 to 2000, so it's really increasing very fast. The Japanese government requested health agencies or universities with the same blueprint to provide information on the living condition and quality of life of the centenarians in Japan. And you can see here in 1973, 37 of the female centenarians were confined to their room. And 20 years or 30 years later, they are 78% in this situation. They started with 22% bedridden, and we are ending with 40% of them bedridden. So we have these two opposite situations. When the number of centenarians is increasing slowly, it seems that the functional health status of these people is improving over time. But when the number is really skyrocketing, like in Japan, their functional health status is clearly worsening. And they are more and more frail and disabled. So this is really helping us to better, to fine-tuning, if I can say, our research question about the relationship between the level of mortality selection and the functional health status of the survivors to very old ages. So I have no research for the time being, but we have established a study, the 5 COOP, for Country Old Project, with these 5 countries, Denmark, France, Japan, Sweden, and Switzerland. And we started in 2011. We have now completed the data collection in 4 of these 5 countries. We are still waiting for Switzerland, but the data collection will be completed this summer. Everywhere, the target was to get a representative sample of people reaching exactly the age of 100 in these 5 countries. So we have 251 people in Denmark, 211, it was my lab, we are not so good in France, 336 in Japan, 274 in Sweden, and we expect to have about the same number in Switzerland. And really, we were putting a lot of emphasis on we want to have representative sample. It is extremely difficult there is a lot of studies about centenarians if you go on the literature, but in fact most of them are using convenient sample. The centenarian I know, the one in my nursing home, in my hospital. So like that we have samples, small samples in general. In some of them, they are all in very good health, so people are just concluding it's so easy to be centenarian and to be in good health and not demented, and some others are publishing 100% of my centenarians are demented. So we don't really know. So here we were really trying to do that. It's very difficult because the family are protecting them, the families are reluctant to open the door to epidemiologists or demographers. So like that you can see in Denmark, our response rate is about 50%, what was expected, but they were expecting to have 70%. And in fact, they got 50%. In France, it's 30%. We were expecting 50%, and it's only 30%. In Sweden, we don't know why. We have to explore that. They got 85%. It's absolutely, so we really have to go on the field to understand how they are making epidemiological or medical surveys in Sweden. And it seems that it will be 33 in Switzerland. I don't know whether you will invite me next year, but I'm sure I will have results next year. And so the second question, or moving at national level, is healthy life expectancy increasing faster than total life expectancy? And a few years ago, an OECD study found mixed results about ADL disability trends. ADL is activities of daily living, is the most severe level of disability when in public health is we are measuring the proportion of all people having difficulties with a very basic daily activity like washing, eating, going to the toilet, so which is really absolutely essential for the daily survival. And this is a kind of standard disability indicator. So out of the 12 OECD countries, so they are rich countries, studied, only 5 of these 12 countries were showing clear evidence of decline of disability among the elderly people over time. And in 3 countries, it was the opposite. they were showing some kind of increase in the proportion of people aged 65 and over suffering ADL disabilities. And in fact, what was really worrying in this study is the fact that the three countries clearly showing a disability decline over time was also the three countries displaying the weaker increase in life expectancy at age 65. So something was not working there. And okay, this is one example of what I said previously of countries establishing a monitoring system in the 80s and keeping it working over time. And this is one country, the Netherlands, one of these three countries where disability was clearly declining over time. So you can see here a clear increase in disability-free life expectancy over time in the Netherlands. So which is fine, and which is what we were all expecting. But at the same time, look, the increase in life expectancy is extremely small over that period. And in fact, you can see an increase only at the end of the period. For almost all the period is flat. So, okay, disability-free life expectancy was increasing in the Netherlands, like in Denmark or in the United States, but these three countries were the countries displaying a very poor increase in the total life expectancy. A little bit like what I said for the centenarians and Denmark previously. So, since 2000, we were able to collect data from at least 16 countries having this kind of monitoring system. And here you have a list. And a close examination of this time series of health expectancies, in fact, suggests that healthy life expectancy or disability-free life expectancy is increasing most in the new emerging countries, such as China or Thailand or Eastern European economies, than in the OECD countries, in the advanced Western economies, except Switzerland, which are really showing a strong increase in life expectancy and in disability-free life expectancy. There is no great evidence of compression of morbidity in the low mortality countries. And it is what I said, the three countries displaying a compression of disability, Denmark, the Netherlands, and the United States, they are the three countries which lag behind the low mortality countries in terms of life expectancy at age 65. I think I already shown that last year. And if you remember, so this is Japan. So you see the increase in life expectancy at age 65 in Japan. But here you have France or Sweden or Switzerland. So you have this very strong increase over time. And here you have Denmark. You see Denmark was diverging. Denmark, the United States, and the Netherlands. So these are not really the good performer in terms of life expectancy. And thanks to the European Joint Action on the Healthy Life Years, we have now a monitoring system. It's a new one, but we have now a monitoring system for the whole Union. And the system started in 2005, and here you can see that in fact in 7 or 8 years the life expectancy increased at age 65 in total for the EU 25, because in 2005 we were only 25, increased by more than 1 year for the males and for the females, and these are the increase for the males, the increase for the females. The gap is between males and females is 3.5 years, and there is no decrease in this gap. So females are living on average at the age of 65, 3.5 years more than males. So this is true, it's the same. But if we look at the disability-free life expectancy, you can see there is no increase at all over that period. It's exactly 0 for the males and an extremely small decrease for the females, but it's not significant. And so there is a strong increase in life expectancy during the last years in Europe, but there is no change at all in disability-free life expectancy. So this is really a strong case of expansion of disability. It is also interesting to see that there is no gap, or very small gap, no gap between the males and the females when we are looking at the disability-free life expectancy. In fact, both are living the same number of years without disability. So the third question, now it's trying to look at a more global level. The question is, do countries with the highest life expectancies have also the highest healthy life expectancies or disability-free life expectancy? And in fact, the previous results may simply be due to the fact that countries having the highest life expectancies also enjoy the highest healthy life expectancies. We are starting from this situation. So in this case, the observation of a strong increase in healthy life expectancy in the other countries, in China, in Thailand, in the East European economies, would be part of their catching up. We are starting in a situation where disability-free life expectancy is much lower in China, in Thailand, in Eastern European countries. So it's possible that, in fact, the stronger increase we observed in the last years was part of this catching up. But it's not, and this could somewhere make more difficult to answer the research question we have. So here we have just studied the correlation again between the European countries, because now we have the same monitoring system, we have the same indicator at the age of 65 for the males and the females, between the disability-free life expectancy and the life expectancy. And it is correlated, but it is weakly correlated. And as you can see already on this scatter plot. And the correlation is specifically weak, 0.42 for the females. So there is a relationship between the length of life, between the life expectancy and the disability-free life expectancy, but this relationship is weak, and obviously there is other factors at play in determining the value of the disability-free life expectancy. So what can we conclude for the time being from these studies and results? The first one is centenarians are a strongly selected group, and the phenomenal increase in their numbers that we are currently observing is essentially due to the fall of mortality above the age of 80 years, and it seems that this decrease in the mortality selection, so the risk or the chance to survive from 80 to 100, has been accompanied by a parallel decline in the functional health status of the successive cohort of new centenarians, at least in Japan. But next year we will have some results for the 5 countries with strictly comparable data. We explored also this relationship between increase in healthy life expectancy and total life expectancy at the country level. to assess whether increase in life expectancy is always accompanied by a compression of morbidity. And we observe that healthy life expectancy increased most in the countries which lagged behind in terms of life expectancy at age 65. So there is no strong evidence of compression of morbidity in the countries with the lowest mortality or with the longest life expectancy. Finally, we examine the correlation between life expectancy at age 65 and the number of healthy life years for 24 European countries. We found a positive relationship, however not strong, between the quantity and the quality of the years lived. Altogether, this result suggests that the strong increase in healthy life expectancy is more a feature of countries which are catching up with the best countries in terms of population health, or men catching up with females. Low mortality countries may not display obvious compression of disability, although they tend to enjoy the highest life expectancies. In total, there is no strong evidence today for compression of morbidity and disability in the countries which lead the longevity revolution. Thank you.
Yes, thank you. Thank you, Jean-Marie, for the excellent presentation. I'm sure that you have questions. Yes, please.
Recently, I have contact with some data of gerontology research group, not from centenarians, but for super centenarians, so above 110. I don't know much about this subject, but I have contact with this data. And fortunately, you were seeing your distributions along the time, and you're seeing that the right endpoint is finite, I think. So we are happy because someday we have to die. We don't know when, but we certainly have to die. So I have been studying this data in order not for the expectancy, but also for the lifespan. So I'm interested in what is the largest here that we can meet. During this time, I also had contact with your very famous Jeanne Calment, with 122 years, and she used to smoke two cigarettes at most, have chocolate every day, and also have a port wine, that is a Portuguese product. So I was very happy because I like to smoke. I also love chocolate, and also I also like to have port wine sometimes. What I have to question about is there any study about the health status of these people that are super centenarians above all the world, and the age that they could reach, or not, what is a very difficult data set, I think, to study about. The two things, the health status and also the most they could reach.
I think I know the group of people you were talking about. I was 2 weeks ago in Osaka in a meeting about the International Centenarian Consortium, and there is a group from Portugal presenting new data about the super centenarians. And it's a very interesting and exciting issue. And we have an international database with about 15 countries participating on this kind of issue, where we are trying to have high quality data about the longest life in the world. It's difficult because to be part of this study, you really have to demonstrate you can provide clear, neat data about people born more than, by definition, 110 years old. So it's very, very, it's very selective. But even like that, we really need people interested by small numbers, by the statistic of the small numbers, because what can we say? What can we say with the age of Jeanne Calment? You were talking about Jeanne Calment, 120 years old. She's totally an outlier. I think when she made this 122 years, the highest known age was something like 112 or 113. So it was 10 years above. And since that time, so she died in 1997, since that time we get more and more cases of people dying around the age of 113, 14, 15, even 16, but it's not clear. And so it's, it's a fascinating, it's a fascinating topic. There is always statisticians or demographers trying to work on this small number. What can we say from these small numbers, from the trend in this small number about the limit, the maximum lifespan of the human species? So if you have ideas how we can use this data, we have more and more data, we have very high quality data. We have, for instance, 200 cases of people having reached the age of 110, dying above, including Jeanne Calment in France between the 1970 and today. And the data are available to everyone who want to work on this, on the extreme values. And just one question, because I validated the case of Jeanne Calment. This was my only chance to have a paper in science, and so I met her before, and I can tell you this is the truth. I was yesterday night on the Swiss TV through Skype, exactly on your question. She was not smoking every day. She was not drinking a glass of Porto every day, and she loved chocolate, I don't know, but she was not eating chocolate every day. At least during the small period of their time, I met her between 117 and 121 or 22. This is more a legend, but the journalists were just so happy with this kind of answer, and they were all, and she was receiving a lot of journalists, and they were always asking the same question, and you are still smoking one cigarette per day? Yes, 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 and they were just so happy. It is why we need highly validated data when we are working on the extreme longevity cases.
Well, okay. Yes?
What is the precise definition of healthy life expectancy?
Okay, I don't know. It is a very good question. We are working on that since many, many years, because health is multidimensional. It is why also we are comparing several types of healthy life expectancy, and there is two schools about that. One led by health economists. They think that health is a latent threat. They just want to mix everything together and just to provide one value summarizing everything. The World Health Organization recently published values on that for all the countries, I think for 2012, the healthy life expectancy based on the global burden of disease. So it's everything, just one value. What we are doing, at least in the joint action, the European joint action, is really computing one indicator for each dimension of health we want to monitor. So we are monitoring three main health dimensions: the functional health, so functioning, the presence, absence of chronic diseases, so the biomedical, the classical biomedical approach. And we are also monitoring the perceived health, how people feel, whether they feel being in good or in bad health, because even if this indicator is highly subjective, this one is the closest to their own quality of life. And also, this is, if people are contacting the healthcare system, visiting doctors or spending health consumption, is related to their own perception of health. If you feel being in good health, you are not spending health consumption, and you are not contacting medical doctors, for instance.
We already have taken 10 minutes from the coffee break. So for us, the coffee break is only 10 minutes, and after we split to the 4 rooms. The 4 rooms are close to the secretariat place, and we'll be here after lunch for a plenary talk, and also for the presentation of University of Piraeus and the University of Malta about the next conferences. So thank you very much for joining.
Thank you.
I met a fellow who was very session in the States. He was in charge of birth and death in America in Queensland. He was in charge of registration of birth and death in America as a state national. And his team went for him. And they found 300 people whose births had never been registered. Never. And I said to him, will this be common? He said, very. Yeah, so I said, he said he had one woman who was 92 and she'd never been had a birth recorded. I said, if she was 90, how did you know she was 92 if you'd never had a birth recorded? Baptism records. I can tell you that these were claimed to we had a man in our town who was 110, and when the Olympic Games came to Australia, he was the one that carried the torch to run along through the city with the torch. You're right, he was a big carrot.
Yeah. So it's...
You said 40% of women in France will live past 90?
Yes. In the mortality condition, you know...
That is hard to believe.
Yeah, you know our